are live.
Okay.
Let's see if
Yeah.
we are live.
I can confirm that we're live.
Can you hear me and you? Was that a yes, Martin? Can you hear both of us? From on your end? If you're viewing it externally.
I can see us live on YouTube, and I'm checking on Facebook now.
Can you check audio for both of us, Martin, on the streams? And just make sure
Yeah.
both of us can be heard.
I can see us live on YouTube. Confirmed on YouTube. I obviously muted myself on YouTube. And let me check on Facebook.
What about me? Can you hear me?
Yeah, I think we're good. I cannot have two audio streams coming in, so
Let me go ahead and ask someone.
I muted the video on YouTube. I'm checking Facebook, and we still have 6 minutes until we're officially live. We're just online earlier this time to avoid any technical issues. So welcome everyone who has already joined us, and thanks for your patience. We're going to start at 4, but make sure we're technically all set this time. So thanks for waiting along with us.
I don't think we're on Facebook yet, so we're going to go ahead and wait for that a little bit longer and just make sure that we actually are online on Facebook. Hi, everyone. I'm Caleb Hassler. This is Martin, and we'll get started here shortly once we can confirm that we're actually live on all platforms.
Yeah, Caleb, I'm not totally sure what's going on the Facebook side. Would you be able to connect with Hans about that and check?
Yes. Give me 1 second to actually go ahead and take a look at the Facebook page. So the video is showing on the Facebook page.
Caleb, did you see Tim in the chat on YouTube is saying that one of us, I think you are on the left, is quieter in terms of the audio?
Alrighty, I will try and make that a little bit louder on my end. Let me just mess with the inputs.
Great.
And I believe we need a new key for Facebook, and I'm putting that in right now.
And it might be that Facebook won't start until it's actually 4 p.m. I see a countdown on Facebook.
Okay. Yeah, I'm gonna go ahead and about now? Is my audio better, guys? Potentially. Well, if we
We'll find out.
someone says it's too loud, then I will turn it down.
I think that's a fair game here.
Right. I'm going to go ahead and close out of the settings. Alrighty. Yeah, and I think that Facebook is going to go live right at 4.
Yeah, we'll check on that. Tim says you're still quiet.
Let me adjust that.
Lucia, can you confirm that that's better on your end, or how we're doing there? And thanks for letting us know, Tim, that it's better. So
Yeah,
we'll make adjustments.
All right, is that any better, guys?
So we're 1 minute down on Facebook until we're live there too. Yeah, for anyone who had trouble watching on YouTube last time, we had a technical issue that only allowed us to stream on Facebook, and we figured out what was wrong. So obviously we're live today here on YouTube. We also uploaded the replay that you can watch on our channel from the last time that we did our live stream. That was with Caleb, who is here today too, and Hans. And that was showing how we made a holiday gift card, a greeting card, and you can rewatch that again on our channel.
Yeah, feel free to skip through all of the LightBurn sections. In the first half, I was not aware that LightBurn was frozen that entire time. So disregard that section. We'll make sure that next time we show LightBurn that it'll actually not be frozen.
Okay, it looks like we're live on Facebook too. And we have a few people in chat on Facebook. We're live on Facebook too as well. So welcome both Facebook and YouTube subscribers. It looks like we're ready to go on both ends. That's the first success here today. And I actually already see one question that came in, Caleb.
Martin, how about we start with a little bit of an introduction maybe before we get into it?
Absolutely. Let's go ahead. You start and I'll follow on.
Sounds great. Hi everyone. I'm Caleb Hassler. This is Martin Angston. We are the co-founders of Rendyr Desktop Robotics, and we are soon to be launching our very first product, the Optic portable laser cutter, which you see right here. It's a complete redesign of traditional laser cutting and prototyping machine in order to make it a better, more human-centered experience. And today we're going to be answering audience questions about the machine, the team, our upcoming crowdfunding campaign. Yeah, alrighty. Martin, do you want to add anything?
Great. Well, Caleb introduced me briefly. I'm Martin Angst, and I am one of the other co-founders besides Caleb, and I work more on the business side, and I'm excited to answer your questions here today as well. So Caleb, why don't we get started? I saw one question on YouTube already that I'm going to throw your way. It's related to the lifetime of the laser diode, mm-hmm. and how we might be able to replace the diode when it might not work anymore. Oh, so would you like to talk about that?
Yeah, of course. So it's both a simple and complicated question. So the simple answer is that each diode is rated to last in excess of 10,000 hours, and our laser module itself uses multiple diodes and then compresses them into a single beam in order to optimize optical output while maintaining a relatively small form factor. I realize it is a small laser module and it is a faraway camera. But if you see there is no sort of obvious attachment mechanism to the rest of the machine, and that's because there is a dovetail on the back of the machine which clamps in to the machine using a lever. So it's completely toolless replacement, making the replacement of the laser module or the cleaning of the laser module exceptionally simple. It can be removed out the front of the machine using no tools. Hope that helps.
Yeah, Caleb, I think I lost your audio for a second when you were finishing up. One thing that
cool.
we didn't hear yet, and Michael, thanks for the question. Sorry I didn't call out your name earlier. Was how long does it last? You might have said that, but I just want to make sure we can answer that question here again.
Yeah. Each of the diodes inside of our module is rated from the OEM as lasting over 10,000 hours at I believe 95% power. So we expect anywhere between 9 and 12,000 hours of continuous on time. And so that means that in the actual machine when it is being used, the laser is not on 100% of the time if you're engraving. Cycling through different power levels. Sometimes when you're cutting, it's not at the maximal power. And so that's the current information that we have on the lifetime of the lasers. But we are doing continual accelerated lifetime testing in order to get a more accurate picture.
Absolutely. Thanks, Caleb, for getting into that question more deeply here.
Mm-hmm. That's a good question.
Here's another one. Let's see what we got. This might be another great one for you to answer, Caleb, and that's related to acrylic and clear acrylic specifically. Mm-hmm. Maybe we can also talk a little bit about glass and how we have been able to engrave on clear glass, and you can talk a little bit more about the specifics between colored and clear acrylic so that we make that more clear in regards to the optic laser cutter.
Yeah, I'm gonna read out the question and then I'll give an answer to it. I remember hearing during the live demo the other day that the Rendyr doesn't cut clear acrylic because it's too invisible. What about acrylic that has facing upwards? So our laser module works largely within the visible spectrum, which means that the actual visible color of the acrylic actually matters to the efficiency and speed with which it can be cut and engraved. And so your darker and more opaque colors of acrylic, whether they be opaque red or green or black or blue, are going to cut and engrave significantly faster than your more sort of translucent materials. And so if you have like a translucent red or a translucent blue or a translucent green, the optic will still be able to cut that and engrave that. It may just take extra passes because the laser is just sort of losing more energy than it would be in an opaque material. And so all the way on the other end of the spectrum, you have clear acrylic, which is totally optically clear. And so that means that the laser has a very hard time getting the material to absorb the energy. And so clear acrylic is really good for engraving. Cutting, we're still trying to find the best settings, but we generally advise against trying to cut clear acrylic with the optic because it takes a long time, and if you don't do it correctly, you can get sort of burning, which is not ideal for obvious reasons. Now, if there's a masking on it, I believe that will help with cutting in thinner thicknesses. We've done some testing with 2mm clear acrylic with masking on both sides, and that is possible to cut. However, it does take 2 to 3 times the time that the opaque and the translucent materials do, but again is generally considered an advanced technique and I'd say not suitable as an everyday material to be used with the machine.
Caleb, why don't we, I saw a question that actually kind of follows on to that. And why don't we take that question here from Jamie before we jump into a few other questions? And that is one that asks, why did we choose a visible spectrum laser? And I think I'll leave you to answer that one as well, of course.
Yeah, so there's really two types of lasers when you're talking about, I would say, medium to desktop scale laser cutting and engraving machines. There's solid state diode lasers, and then there's CO2 gas lasers that are used in some large machines like Epilogue and Universal Laser Systems. And those large glass tubes can be anywhere between 24 and 36 inches long, depending upon their wattage. Some go even larger. I believe you can get up to 500 watt CO2 laser before having to move over to either, I believe it's lamp pumped or fiber lasers. And they're pretty large. They require routine maintenance. They are very delicate, and they actually do not last as long as solid-state diode lasers under most operating conditions. And so, for all of those reasons, it was so the best choice for our application to go with a solid-state diode system. However, the solid-state diode systems that are in any sort of, I would call, engraver on the market right now are less powerful than the optics module, because the optics module utilizes multiple high-powered diodes as opposed to some, I would say, import engravers which use a single sort of gray market diode that is going to be generally less powerful than even a single one of the diodes that we have inside of the optic. So the optic really allows you desktop laser cutter performance without the downsides of a glass CO2 laser tube.
And actually, we're so focused on the laser right now, so I think it will please everyone if we stay with that for a moment and talk about cooling as well. There was one question related to cooling, and I think when we think of cooling, especially in terms of the entire design of the optic, not just the laser module, it's really important to understand how that keeps the performance of the laser very high and also makes the laser itself better really than any other one that is comparable in this class on the market. And could you go into that a little bit more?
Yeah, definitely. So the optic laser module is a completely custom in-house design which partially utilizes the airflow for filtration for its cooling, but the optics laser module also has two active cooling fans which also help to remove particulate and fumes from the optical path. So the optical path is from about the midpoint to about 15 millimeters below the bottom of the laser module, and that entire area is kept clean of debris and particulate because of the wind tunnel basically created by the two fans. And so that is another reason why we can have such high cutting efficiency to be able to compete with the larger glass tube lasers.
And it's probably going to be difficult right now to pull up the temperature curves that we had used during testing of the laser diodes that show how we don't go above a certain temperature that would potentially damage diodes to really ensure that the lifetime can last as long as we promise here.
Yeah. As I mentioned previously, the Optic is currently the most powerful diode laser cutter available. That was one of the goals that we set out to do, and to do that we had to really design from the ground up its cooling system and its filtration system. And that means that we were able to make it so that there's actually 0 duty cycle under normal operating conditions. That being, you know, like room temperature. And in a room that is room temperature, you can continually use the optic continually, and it won't ever overheat. But if you are in a very hot garage, it's like 105 degrees outside, maybe you're in California, you can use the optic until it gets to a temperature that it deems too hot for the safety of its diodes, and then it will know that and then stop before any damage to the diodes or the machine or the workpiece could occur, because there's active temperature monitoring inside the laser module right at sort of the thermal mass of the diodes.
Great. Well, thanks, Jamie, for all those questions. We hope we answered those for you here today. I think, Caleb, why don't we shift gears a little bit towards a slightly more philosophical question here from Nazari. That is a very interesting one, and I think we need to bounce between the two of us here. I'll just read it out for everyone because I think it was asked on YouTube. It is, would you rather consider your laser engraver more as a very expensive hobby toy or as a low-cost professional tool? So again, I think that's a more philosophical question. It also is a question that is not necessarily purely ours to answer. But from our perspective, or from each of our perspectives, Caleb, what do you think?
Well, okay, so I got two options here. I got expensive hobby toy or low-cost professional tool. If I had to start off with, I'd say that we're probably 3/4 closer to the low-cost professional tool. Because of the amount of value that we're offering at the price point that we're offering it, we feel as though we're a completely new and revolutionary tool for prototyping and even low-volume production. The Optic not only allows you to cut and engrave 99% of the things that you could cut with, say, an Epilogue or a Glowforge, it also, you know, it folds up and it gets out of your way when you don't need it, so that you can actually, you know, use the table space that it took up when you're not using it. And, you know, that's cool in and of itself, but also the Optic is the only laser cutter that has the ability to actually pop off the cutting mat and then accurately position itself in a way that you can index and engrave designs as large as you want to on any thickness or type of material. And that is something completely unprecedented, and we're really excited to see what people do with that capability.
That's right, and I think thinking back to our time in Washington, D.C. area with various makers, small businesses, in fact, who have used the Optic to create various prototypes and products, it proves as a very, very exciting tool for small business owners. That certainly proves Caleb's point here. It's a very versatile machine, but it also allows small businesses to go really from prototypes to product to small batch production. We don't think that holds anyone back from using it as a, we don't really like to call it a toy, but as a machine for their projects, for really anything that they would like to make at home. We think that this machine fits in any home and folds up easily to be stored away. That's what we designed it for. It doesn't permanently occupy space, and that really is a game changer here. Caleb, I'll let you go again. Sorry.
I just wanted to add one more thing to it. Since we're being philosophical about it, we really designed the Optic as a machine that would accommodate the user's workflow instead of the user having to, you know, drill a hole in their wall to run an 8-inch tube through it and then have like a loud, like gigantic $1,000 air scrubber to go with it. Like, we've designed it as an all-in-one system. It uses the laptop charger that you probably already have. We also ship one. It has an integrated filtration system which captures all of the fumes and odors from the laser cutting process, which is something that is completely unique in laser cutting, and it really allows you just to set it on a table and immediately start using it. You don't need any high voltage power supplies. You don't need a dedicated desktop computer to sit next to it, and you don't need a dedicated air scrubber or a tube to run out of your window. And so we've just really tried to systematically remove all of the things that traditionally suck about laser cutting, while keeping the thing that's really cool about laser cutting, which is, being able to use thousands of different materials and customize the things that you already have. And yeah.
So one last thing back on that question is we really appreciate all the survey responses from you guys, and in those responses we've learned that roughly 45% are actually either interested in building a small business or have a small business and consider getting an Optic for themselves, and there are probably about 40% of personal users that are considering it. So again, I think back to the beginning of our answer for this question, it's not necessarily ours to answer. It's a quite unique product in the range of fabrication tools available, and we're all about reducing the limits, not defining who it's for here. So why don't we jump to the next question here. You talked about this just a little bit now, Caleb, and you mentioned how the filtration works, and there was one question here from Will, I think on YouTube. How does this dissipate fumes and or filter toxic fumes? And why don't we talk about both, sort of how the filter works, how we've gone through the filter development, and also what another option in the future as an alternative looks like.
Of course, yeah. So there's a lot to unpack here. I'm going to stand this for a second. So this is the Optic. And if you have a piece of material, it goes either on the cutting bed, or if the cutting mat, has been removed, then you would be engraving directly on the surface below it. And then behind this shield right here is what we call the X-axis chamber. And this is sort of the main chamber in which the fumes are initially captured. And so there is a slot in between this orange shield and the back of the chassis. And then the fumes get pulled up through that slot. They sort of get vacuumed up either by the laser, if the fumes are directly underneath it, or if they're coming from a different section of the workpiece, then they get vacuumed up by the airflow through the chamber. So there are two fans on the laser which sort of vacuum up the fumes as they are created. And then there are two significantly larger impeller stack style high pressure fans right here, which pull the fumes up into this chamber through a pre-filter, which is washable and replaceable right here. And then it moves through the filter and then is exhausted downward right here. Let me go and grab my filter. Let's play. Where's the filter? Here's the filter. And so this is what the filter, just make sure that I'm on camera. Yes. This is what the filter looks like. So it is made up of two primary sections. There is a large mechanical filtration section up here, and then a smaller activated charcoal section down below. And so this upper section right here has HEPA level mechanical filtration for the physical particulate, and then this lower level right here is I don't know if you can hear it, but it has activated charcoal in it, which captures.
I think too densely packed to hear it, Caleb.
Which captures any sort of noxious fumes or VOCs that are created during the laser cutting process. And then once the filter is full, the machine will alert you, and then you are able to replace it by removing it out of this section of the machine, and then you can load in your new one, and it slots into place just like that.
Fantastic.
So that is the integrated filtration. However, the Optic is a modular system, and so as an additional kit, if you had an external fume scrubber, potentially if you're working in a lab environment, or if you have another laser cutter that already uses a filtration system and the Optic is an additional machine to your workflow, then you would be able to purchase the hot swappable exhaust module, which looks like this and gets slid in place of the filter, and then has a magnetic cap that is removable to show the vacuum port. And then you were able to attach this vacuum tube, which comes in the kit, and then it gets sort of clamped to the table, and then from there you can attach whatever fittings, attachment, tubes, scrubbers, whatever would fit your needs. And then to attach it to the table, there is this table support, which folds out like this, and then you clamp it to your table.
And Caleb, I think it's really great seeing this here right now. We should also make everyone aware that there will be a video that we have here coming soon that shows really well how this works, specifically the exhaust module.
And all of this is going to be in detail on our Kickstarter page. We're working on videos and diagrams for that right now. And so that would allow you to either attach it to a system which would directly vent it outside, or it would allow you to attach it to a pre-existing fume scrubber, potentially like a BOFA unit, if your specific use case required that.
Great, and just like Caleb just said, use case, that gives me a point to jump off. I think really it's about, do you prefer having the flexibility and the integrated filtration, which is exactly why we designed the Optic to include filtration and have these very small, compact filters that can filter the fumes for your projects wherever you need? Or do you sometimes have situations where you might be in a wood shop or so, and you have a lot of cutting to do and you just want to attach it to a vacuum? We don't want to limit your choices here, and so we've designed it with options for you to choose from. Does that make sense? Right, Kellen?
Totally, yeah. That's a great point, Martin.
Okay, well, there is another really great question here from Nazari. And thanks, everyone, for all the awesome questions. We might not be getting to all of them today, but we'll try our best. Here's one that is about software. I'll read it out loud. Would you be able to tell us more about the software that goes with the engraver and laser cutter, including the necessary drivers and the G-code generating app? And some of you might be familiar with a software called LightBurn. We started building on top of LightBurn and making a package that is very specific for the Optic that has additional macros so that you can easily home the machine or do a number of other functions. And it also includes a material library. So we've been developing the right cutting settings for power and speed, for passes and other aspects that all come with the software. And let's talk a little bit more about why we chose LightBurn. To some degree, that's another one of these philosophical questions. Why did we choose LightBurn? Why didn't we do our own software? I'll let you start here. You smile like you're ready to go there.
Yeah, well, so after kind of taking stock of the available software options for laser cutters, on sort of the low-end import diode end, you have Laser Gerbil, or the OEM software, which is included with these import machines, which if you've ever experienced that, you feel pretty uneasy when you hit that download button for that software that comes on that flash drive. And the other option is the software that comes with your Epilogue or your Glowforge, or your universal laser system, which significantly restricts a lot of the ability to sort of customize and change things according to your needs, and it just doesn't really have that much functionality outside of being able to load in a vector or an image and then hit go and kind of hope that it works. And in the case of the Glowforge, it actually requires you to have a Wi-Fi connection, which we found to be somewhat annoying, and lots of other users that we've spoken to have also found it annoying, specifically in lab environments where you have locked down networking that sort of prevents some of that software from being used. And then you have sort of the more open source options. So other than those two extremes, there are various plugins for programs like Inkscape, which allow you to generate laser G-code. And then there are a few other sort of web-based applications for generation of laser G-code. One is called Laser Gerbil, I believe, and I believe it runs in your browser. But the sort of best option, you don't have to take my word for it. Any amount of sort of community engagement and research would show that it really is sort of the audience choice for the best software for any laser cutter is LightBurn, because it not only allows you to use that software for the low-end import machines, but also allows you to use it with like higher-end machines, whether it be a Ruida-based controller system or an even larger semi-industrial laser. So it's a software that has folded in a lot of the features from vector programs like Illustrator, Vectorworks, and Inkscape, while also folding in all of the necessary G-code generation and CAM operations that you would find in something like Fusion 360. Now that being said, it is a extremely powerful program, but that means that it could also be very complicated for a newcomer to laser cutting, CAM, or CNC. And so we have taken LightBurn and we have created what we are calling the Optic version of LightBurn, which is a set of settings, preferences, and material libraries that you would load into LightBurn, which arranges all of the tabs. It sets the proper build plate. It calibrates and orients the software work plane to match the physical work plane right here. And then it also adds extra macros as to what Martin was saying. One extra button brings the Optic to the fold position, which puts it in the proper position in order to do the folding. And then there are other macros which move the y-axis all the way down and then all the way up for quick and easy maneuvering and positioning of material. And then, of course, our material library, which we've been continually tuning for more and more materials and which we're constantly upgrading and working on. And so we've really tried to take a super powerful software and really tune it in for the Optic so that you get all the advantages of that software while also having a great user experience when first using the Optic. And then other than LightBurn, we also have a post-processor available for Fusion 360 if that is your CAM modeling tool of choice. And for pretty much everything else, you can just drag and drop them directly into LightBurn, whether you're dragging and dropping an image or any vector from any other program. It really allows you sort of universal operability.
And to make the last part that you said even more clear, vector image, that means you can really use a file from Photoshop, a PNG, a JPEG, a DXF,
any image or vector file.
A vector file like an Illustrator file. We have so many options, and you just pull them into LightBurn, and then you set up the file that you pulled in with the right cutting settings and so on based on the material library, and you're pretty much ready to go. So we're really happy with having chosen LightBurn, and so far we've been getting really great feedback because people who know about LightBurn are pretty excited that we made the Optic available to be used with LightBurn.
One last thing on software, Martin. LightBurn is a paid software because it's awesome, and one license is included with each Optic, which allows it to run on 2 computers, and so that you don't need to worry about like buying it or anything. It comes with the machine. And I see a fun question that I would like to answer.
Okay, go ahead, Cam.
Is there anything in the work for a rotary attachment? Yes, and we are very excited to, hopefully we'll have that ready for the Kickstarter. But yes, a rotary module is definitely in the works.
Excellent. I still see so many great questions, and maybe we can go a couple more and then wrap up here, because we wanted to keep this live stream a little bit shorter so that it doesn't take too much time for anyone to watch the replay. And we'll be live here next week again. So happy to answer more questions. And I've seen a few questions related to a demo. Today, we decided not to do a demo so that we can get to more questions. Next week, we're excited to do another demo, and we're still thinking about topics. So please let us know if you have anything on your wish list that we can consider. Send us an email. If there's
any specific material or any specific type of project that you guys would like to see us do a demo of, we would love to see what you guys are interested in, and we can make that happen.
Absolutely. Leave ideas in the comments here. Facebook, YouTube, wherever you like. Email us at hello@Rendyr, and we'll consider all of your ideas for the next live stream. Before that, Caleb, do you see here anyone that you would like to pick as a final question?
It's a lot of pressure. Hold on.
Maybe why don't you take a look?
Custom soft. Oh, I'm sorry, Martin.
Okay, you can take a look. I see here one that's a bit more general. Launch, timeline, pricing, etc. From Madeline on Facebook. And it's a great time to talk about that a little bit before we wrap up here. And then we can get to one more from the Caleb chooses. We are launching very soon on Kickstarter, which is a crowdfunding platform. I think many of you are familiar with that, and some of you will hopefully be soon. We are targeting January as our launch date. We don't have an exact day yet, but we will communicate that here very soon. In terms of the timeline, the crowdfunding campaign typically takes somewhere between 30 and 40 days. We'll have a specific number for you as well coming up soon. Pricing, we've been communicating with lots of you who have asked questions, and we're still talking with our manufacturers and tuning in. Of course, our goal is to be priced as low as possible, and we're currently going to be, for the pre-launch price, somewhere between $1,700 and $2,200. But there will be more updates on that soon as well, because things are dynamic. And then let's see, are there any questions that we could answer related to the launch? There will be a limited number of optics available. You can imagine that a launch like that with high demand is a big task, and we want to make sure that we deliver all the optics to you as early as possible. We estimate somewhere between 6 and 9 months for delivery after the campaign ends, and so we want to cap the number of units that are available to accomplish that. For anyone who has participated in past crowdfunding campaigns, you know that some of these can be a challenge, and we're doing everything in our power to really deliver to our customers as early as possible. And one part of that is limiting that. The other part of that is, and I'd love to show a picture, but we'll upload that to the Facebook group soon. And if you haven't joined the Facebook group yet, please do so, of our samples that we've already received from manufacturers, and we're doing really great on that. I think Caleb is going to go and grab a few things here. And that is, of course,
I might break everything. We'll see. Well, let me answer the last question, and then I'll move the camera.
Okay, that is, of course, a big part related to a fulfillment timeline. We're making great progress on the manufacturing, have received tons of samples already. And with that, I'll hand it over back to Caleb again.
Yeah, I just want to add a little bit more to the timeline and pricing question. I know that this sort of sounds like what everyone is saying right now, but the reason that we're a little bit fuzzier than we would like to be on both the pricing and the time estimates is because of the pricing and shipping fluctuations due to COVID-19. Our machine is made of multiple components which come from multiple suppliers and manufacturers from all over the place, and so we're just really having to work with changing timelines from our manufacturing partners. And there is one other question that I wanted to talk about. Without custom software, how do you accomplish alignment for the extended workspace feature? That's actually a base feature within LightBurn. LightBurn, in and of itself, allows you to index larger designs than your laser cutter by cutting and tiling them, and then it allows you to then index the laser by pointing the laser to predefined points on the artwork. They can be any points on the artwork, and then you tell LightBurn that the laser is over top of those points, and then it automatically adjusts and then changes the next tile in the sequence, meaning that you don't need to be super precise when you're moving the machine. However, our machine has the ability to do that in 2 axes as opposed to the machines that feature is largely meant for. So on traditional machines that have like a pass-through window, that means that you're limited by the width and you can only pass the material through in one direction. However, the Optic allows you to index in multiple directions, allowing for a truly infinite size work plane and workpiece. Alrighty, and that I think is going to be our last question.
Okay, Caleb is grabbing a sample from the manufacturer. Yeah, and related to that specific feature of LightBurn that we designed Optic around too, it's really unique that you can go into both axes and position everything so exactly. Let's just wait for Caleb until he comes back with a few pieces.
I'm trying to figure out the best way.
Regarding all the other questions that you have, we will make sure to get to some of these in the next live stream too, and potentially include them in our FAQ, or even respond to you via email if you send us that question to hello@Rendyr, or anywhere on social media, Facebook or Instagram works as well.
I was just going to show a couple of
Please know that we're not ignoring your questions. We
just showing a couple samples that we were taking pictures of.
Oh, would you mind staying on that frame for a short moment? It was maybe a little bit too short to get that.
Yeah, and this is just small amount of our samples that we were taking some video of.
Great. Well, you will get a picture of that here very soon. Of course, we have a lot of goodies coming for you. So thanks for tuning in today. And
thank you guys so much.
Spending time with us and learning more about the Optic. We're really excited to get this out to you, and working hard to have that launch happening here soon on Kickstarter.
Thank you guys so much for joining, and have a happy new year. Yeah. Alrighty. See you guys next week.